Today's class I am going to teach about how to write the test bench Verilog HTML code and also normal Verilog HTML code for 8:3 encoder cycles. So and also we verified the test bench waveform with the help of ICARUS Verilog and GTK web tool. So we will discuss one by one. So first I draw the block diagram for 8:3 encoder cycle. So it's a block diagram 8:3 encoder. It has 8 inputs. 8 inputs that namely called as D0, D1, D2, D3, D4, D5, D6 and D7. It produces 3 outputs A, B, C. So these 3 variable are considered as output variable. This 8 variable considered as a input variable. Now I am going to write the truth table. So based on the truth table, writing the Verilog HTML program. So truth table. So input variables are D0 to D7, D7, D6, D5, D4, D3, D2, D1, D0. The output variables are A, B, C. So D0 value 1, remaining all the bits set to be 0. So now output of the encoder is A, B, C. All the 3 values goes to 0. Then D1 value 1, remaining all the values goes to 0. Then D2 value 1, remaining all the values goes to 0. D3 1, remaining all the values goes to 0. D4 value 1, remaining values goes to 0. Then D5 1, remaining bits set to be 0. D6 1, final one D7 value 1. The corresponding output of 8:3 encoder. So here 001, 010, 011, 100, 101, 110, 111. So it's the input of 8:3 encoder. It's a corresponding output. The corresponding hexadecimal value is 01, 02, 04, 08, 10, then 20, 40, 80. So it's a hex value. So hexadecimal value for the corresponding inputs. So first input considers 01, then 02, 04, 08, 10, 20, 40 and 80. So it's a truth table for 8:3 encoder. So now I am going to write the program. So as usual, first you write module, then module name encoder 83. So it's a module name. So here just to mention the variables. So input variables and output variables. So D, A, B, C. Totally 4 variables are used in the encoder circuit. Then declare the input variable and output variable. So input variable, it's a vector format 7:0 D. Then output variables are A, B, C. So A, B, C. It's a output variable. So then assign. So assign the value for C. So C equal to, when C value equal to 1, so hex value 2. So 2 and 8, then 20, then 80. So C value equal to D1. So D1 plus, then T3 plus D5 plus D7. So in this particular input only C value is set to be 1. Then next assign B. So D2 plus then D3, D6 and D7. D6 plus D7. Then assign A value. So D4 plus D5 plus D6 and D7. Then N module. So here semicolon. So it's a normal Verilog HTML code for 8 to 3 encoder. Now I am going to write the test bench Verilog HTML code for the same. Then come to test bench code. So as usual, first write module. Module name is test. Then declare the input variable and output variables. So input variable declare as register and output variable declare as wire. So reg 7 is to 0 D comma semicolon. Then declare the output variable as wire A comma B comma C. Then module name, while writing the Verilog HTML program, that module name is encoder. So you write that name. Then DUT, so DUT for device under test. Then declare the instantiations D, A comma B comma C. So then initial begin. So begin the process. Then del of dump file test.vct. Then del of dump variable 1. So these two instructions are used to simulate the test bench Verilog HTML program. Then declare the input variables. So D equal to 80 H. This H represent hexadecimal number. This 8 represent 8-bit value. So here input is a 8-bit value. That input value represent in hexadecimal numbers. So 80 H 0 1. So after 10 nanoseconds, change the D value. So D equal to 80 H 0 2. After 10 nanosecond, D values change from 02 to 04. 80 H 04. After 10 nanosecond, D value equal to 80 H 08. So after 10 nanosecond, D value goes to 10. So D equal to 80 H 10. After 10 nanosecond, D value equal to 80 H 20. Then D value equal to 80 H 40. After 10 nanosecond, D value goes to 80 H 80. So far initializing the input values, then end. So end the conditions. Then initial. So now we monitoring the output. So begin del of monitor. So del monitor. So in bracket A equal to %B D equal to percentage B. So this percentage B represent binary representation. So output A value, B value, C value. All the three values represent in binary. C equal to percentage B, comma A, comma B, comma C. Then end. So end the monitoring operation. So finally close the module. So end module. So it's a simple test bench Verilog HDL code for 8 to 3 encoder. Now we are going to verify the result with the help of ICARUS Verilog and GTK wave tool. So far we discussed the programming concept of 8:3 encoder circuit. Now I am going to demonstrate how to see the test bench waveform for 8:3 encoder circuit. So it's a program encoder 83 and encoder 83 TB. So this one is the normal Verilog program. So already we discussed. Encoder 83 TB is a test bench program. So it's also we discussed. Now I'm going to open ICARUS Verilog. Just double click on this icon. So here I choose bin folder. So in this bin folder, I just copy these two document, these two notepad file, and paste it here. Then minimize. Then go to command prompt cmd. First I type cd space, then find the file path name of this bin folder. I just copy the path and paste it here, then press enter. So let's go to that folder. Here I just give the command iverilog -o my design, then to give the file name for normal Verilog HTML code and test bench Verilog HTML code. So the file name is encoder 83.v, then space encoder 83 tb.v, then press enter. So no such file or direct. I made a small mistake, encoder here, spelling mistake. So once again I type the command iverilog -o my design encoder 83.v space encoder 83 tb.v, press enter. Now I am going to compile this program vvp my design, then press enter. So it's a output. So first input value D1 is D0 is set to be 1. So in this case, A value 0, B value 0, C value 0. So likewise, the output is produced based on the code. Now I am going to see the output with graphical window. So I just give the command gtk wave test.vcd. So test.vcd. Then press enter. So it's a graphical window to see the test bench waveform. So just click this icon test and show the signals. So type of signal is wire and register. That signal name A, B, C and D 7:0. So first I choose the input, then insert.
So input value is 0, 1, 0, 2, 0, 4, 0, 8, 1, 0, 2, 0, 4, 0, 8, 0. These all the number represent hexadecimal number. Then choose the output C, then B, then A. So it's a output waveform. So when D1 value, sorry, D0 value equal to 0, 1. So in this case, all the outputs are 0. When is the 0, 2. So D1 value is goes to 1. In this case, C value is enabled. Remaining all the two outputs are goes to 0. So these conditions already we discussed in the manual calculation and also programming concept. So this is the test bench waveform for 8:3 encoder circuit. I hope you understand the concept very well. If you are watching first time in my video, kindly subscribe and support us to make a lot of videos. Thanks for watching my channel. Thank you.